Dear students, welcome to the class of digital signal processing. We have already done the properties of DTFT, and today we will be starting with some numericals on DTFT, and obviously we will be doing inverse DTFT. We have mentioned the formula for inverse DTFT, but today we'll do some questions on inverse DTFT because that has been left untouched. So we'll start with inverse DTFT only, and then we will move on to some extra questions on DTFT, maybe one or two. Okay, let's get started. So first see what we are doing. The major thing is that we are doing inverse DTFT. Okay, so it is called inverse DTFT. What is the formula for this? See, firstly, when you were given xn, you were taking the DTFT, then you were having x of ej omega. Now what is happening that you have been given x of ej omega and you have to find out x of n. So this will be done with IDTFT, inverse DTFT. That will give you x of n. The formula for this x of ej omega is 1 by 2 pi minus pi to pi. Sorry, here I have written x of ej omega. You're finding out now what x of n. So the formula for this is x of n is equals to 1 by 2 pi minus pi to pi x of e j omega into e to the power positive j omega n d omega. So you are integrating with respect to omega, and the Fourier transform of xn is actually continuous and periodic. So you can see that we have used the integral sign over here instead of the summation sign, and this is periodic with 2 pi. Now, let us do a question on this. So you have been told to find the inverse Fourier transform of inverse Fourier transform of the following. So let us see what's the question. The question says x of ej omega is equal to 1 when the value is between pi by 4. This is mod given here, and this is 3 pi by 4. And the rest of the values, for the rest of the interval, the value is 0. What would be the rest of the interval? Because this is between minus pi to pi. So the leftover intervals are what? Minus pi, this one. The leftover intervals will be 3 pi by 4 to pi. Mod of omega less than equal to pi. And directly I am writing in terms of mod omega. So it's written in this manner. 0 to mod of omega and then less than pi by 4. So if you will understand more clearly when I draw the diagram, this is x of ej omega and you have to find out x of n. So this is my x of e to the power j omega. This is omega. Now if I take this point, let us enlarge this more. This is minus pi and this is say pi. Then here you will be having minus 3 pi by 4. Here somewhere you will be having minus pi by 4. Then here somewhere you will have pi by 4. Then 3 pi by 4. If you draw this, at this point the value is 1. And at other points it is 0. This is 1. So this is the diagram. Since mod was given, you have to understand that it will range from minus of that part also and the plus of that part also. So from pi by 4 to 3 pi by 4 and minus pi by 4 to minus 3 pi by 4. And same thing with 0 also it happens. Now we have to find xn. So for xn, you know the formula right now we discussed it, 1 by 2 pi minus pi to pi x of e j omega, e to the power of j omega n d omega. But here, since it is only for certain interval, we will change the interval from minus pi to pi. It's not there. Only it is existing for what? Minus 3/4 to minus pi by 4. Value is 1 into e to the power j omega n d omega. On this side, it is existing for pi by 4 to 3 pi by 4. The value is 1 into e to the power of j omega n d omega. So the variable here is you are integrating over omega. So keep this 1 by 2 pi outside. Simple integration you have to do. Exponential function, the integration is the exponent itself with jn, because omega is the variable, minus 3 pi by 4 to minus pi by 4 plus, again the same thing, the value is going to be same, e to the power j omega n by jn, and this is from pi by 4 to 3 pi by 4. You put the values now. So this jn is, these values are for what? For omega. So what you can do is put jn outside, 1 by 2 pi jn. Now inside you will put the values of the limit. So it is minus j pi by pi n by 4 minus j three pi by 4 plus e to the power j 3 pi n by 4 minus e pi n by 4. Now see over here, these two are the same thing. They can be written as sine 3 pi n by 4. But for that, you will have to divide this by full thing by 2j. Everyone wants 2j. So divide them with 2j. This side, this 2. This one and this one. This is also sine, but there is a small difference. This is minus over here. So what I'll do is, if I take minus common, and then write, then this one will become positive, this one will become negative. So what I can do is, I'll write here minus sine pi n by 4. So this becomes, this 2j will come out. So it is 1 by 2 pi j n into 2j. Okay. Now how much does it become? 1 by j into j square minus 1. So minus 4 pi n. And this is sine 3 pi n by 4 minus sine pi n by 4. So you found out this is what? This is your xn. So this is the method of finding xn from x of e j omega. You need to integrate with this formula, with the help of this formula. Okay, that is x of e j omega e to the power of positive j omega and d omega. So this was a question on inverse DTFT. Just you need to remember the formula, but yes, you need to plot the functions correctly. This mod of omega, here it means that plus omega and minus omega both. So if you take plus omega case, it is changing from pi by 4 to 3 pi by 4. If you take minus omega, then it is from minus 3 by 4 to minus pi by 4. Okay, now let's do one more question on inverse DTFT. So determine the signal corresponding to this Fourier transform. The question can be given like this. Determine the signal corresponding to this Fourier transform. The Fourier transform is given as x of e j omega equals to e to the power of minus j omega e to the power of minus j omega 0.5 plus 0.5 cos omega, 0.5 plus 0.5 cos omega. So see, one method was by directly using the formula. The second method is that you need to compare it, because you see some questions you did where the sequence was completely discrete. In that case, you just needed to put the value at those points like 0, 1, 2. So those type of signals can also come. So that signal will have cos or e to the power minus j omega directly. So here it is e to the power minus j omega. Let us simplify it and put it in the form of e to the power only. So this one will be what? E to the power j omega plus e to the power minus j omega by 2. Now if you simplify it more, it is e to the power minus j omega, which is 0.5 plus 0.25 e to the power j omega plus 0.25 e to the power minus j omega. Now multiply all with the outside e to the power minus j omega, then you will get final x of e j omega. It will be equal to 0.5 e to the power minus j omega plus this both when multiplied will become 1. It is only 0.25 and this one will be 0.25 e to the power of minus 2 j omega. Now if you compare it with the formula, compare it with the formula of x of e to the power j omega, which is given as n equals to minus infinity to infinity x in e to the power of minus j omega. So here you can see, if you solve some questions, then you will understand that this can be written as x of this one. Here the value of n is equal to 1. Here the value of n is equal to 0. And here the value of n is equal to 2. So just let us once check. Okay. Now here it is 1. Yeah. So 1, 0 and 2. So 0, 1 and 2. So basically you have x of 0 as 0.25, x of 1 as 0.5, this is x of 1, so this is 0.5, and x of 2 as 0.25 again. So once again, just see one more thing. I'll write here itself with a different color. So this one is what? Here you can write this as 0.5 e to the power minus j omega 1. This can be written as 0.25 e to the power minus j omega 0. And this can be written as 0.25 e to the power minus j omega 2. So this is the value for x of 2. This one is for x of 0 and this one is for x of 1. And you've got the signal. This is how you took out the inverse DTFT. So one question we did where we took out the DTFT by using the direct formula, and the second one we did where we use comparison with DTFT. So these type of questions can come. Now let us do one more question on this. Okay, the question is find the inverse Fourier transform of x of e j omega. Find inverse Fourier transform of x of ej omega equals 1 plus 2 e to the power minus j omega plus 2 e to the power minus 2 j omega plus 3 e to the power minus 3 j omega. If I write it in a way like this, since it is constant, there is no e, so I will take n equals to 0 for this case. Then what it becomes is x0 e to the power minus j omega 0. Next one, I'll write it as x1 e to the power minus j omega 1, x2 e to the power minus j omega into 2 plus x3 e to the power minus j omega into 3. So see, if you put the 0 value here, then it is going to become 1 and x0 is 1, so this is 1. Here if you put the value 1, then it is going to become minus j omega, which is here, and x1 will become 2. Here you are putting value 2, then it is minus j omega is there, only 2 was there, so this is e to the power minus 2 j omega. Same way, this is e to the power minus 3 j omega, and this is 3. So what you get? X0 is equal to 1, x1 is equal to 2, x2 is equal to 2 again, and x3 is equal to 3. This is your x of n. The inverse Fourier transform for x of e to the power of j omega. Okay, now let's do a question for finding in Fourier transform, that is finding the DTFT. Find Fourier transform of xn equals to a to the power mod n. Now see, this is a discrete time signal, but you can think of it like you will take out DTFS, or so here it's given Fourier transform, right? And they are not asking you Fourier series, otherwise it will be S over here. And the second thing is that this signal is not periodic. So when the signal is non-periodic and discrete, you take out the Fourier transform for that signal. So this is a way of identifying what you have to take out, DTFT or DTFS, if just Fourier transform is written there, if in case you get confused. So again, we'll go directly with the formula, but we'll be drawing the diagram. We take n equals to minus infinity to infinity, xn e to the power of minus j omega n. Now this is a to the power of mod n. So the diagram a to the power of mod n, if you draw, the value at 0 is 1. And after that, the value will go on decreasing. This is the diagram. So this is existing from n equals to minus infinity to minus 1. This value will be a to the power of minus n, e to the power of minus j omega n. And for n equals to 0 to infinity, the value is going to be a to the power of n, e to the power of minus j omega n. Now these are geometric, infinite geometric series only, but you need to find out the values with certain caution. Now if you change this, just as we used to do in Z transform, it is going to become 1 to infinity. And also, the sign is going to change. Both this minus n and this minus will become positive, e to the power j omega n. Here it is n equals to 0 to infinity. We will directly take this as, right? Now here you see, you can write it as n equals to 1 to infinity, a e to the power j omega whole to the power of n. Now for this one, this first term is 1, and common ratio will be a into e to the power of minus j omega, right? So the value is going to be 1 by 1 minus a e to the power of minus j omega. And for this one, since it is starting from n equals to 1, the first term is this only. It is going to become a e to the power of j omega divided by common ratio is the same, a e to the power j omega plus 1 by 1 minus a e to the power of minus j omega. Now, if you simplify this finally, then it will be a e to the power j omega by 1 minus a e to the power j omega plus e to the power j omega by e to the power j omega minus a. Now, after this, you will have to do certain calculations to make it more simpler. Otherwise, this is your answer for x of ej omega. Okay, so this is the way how you are going to take out the Fourier DTFT or inverse DTFT. Thank you, everyone. In the next class, we'll start the DFT.